So we'll continue our discussion from where we left into the last module. What we have achieved so far, we have created this architecture in which we have a VPC ready. There are subnets available in that VPC, and as soon as I created the VPC, I automatically got some additional resources created for me, and those resources I have listed here: DSCP option set, main route table, ACL, and security group. In this section, I would focus on this component which is called main route table. Let's first understand what is a route table. Route table's main purpose is packet navigation. If I give you an example that how it would be easy for you to understand, let's say you are into one city, let's call it City London. And from here, maybe you want to go to another city. Sorry for the scribble. Let's say from here you want to go to another city, let's say Cambridge. Right. Now, let's consider we are going by car. I would drive and I would go from London to Cambridge. Obviously, I do not go every day, so I may not know the path. What I would need for that, I would need to take help of some navigation service. In that navigation service, probably Google Map, I would enter my destination and then it will tell me, hey, go to this road, go to that path, take this turn, go roundabout, and that all information will be provided to me by navigation service. That is my route table. Similarly, in a route table in a VPC, there would be entries which will navigate packet or which will ensure that packets are sent on the right path. Now, like if it is a Google map which is I am using, and if Google map is aware about that location, then only it can navigate me. Maybe there may be some path, like let's say a military base. That military base may not be part of Google Map. So though it physically exists, but my Google Map won't be able to tell me how to go to that particular location because it is off limit from Google Map. So that military base won't be displayed to me. Similarly, a route table would be only forwarding the traffic to the destination it knows about. If a destination is not known to the route table, it would say, sorry, I can't take you there. I have no idea how to go there. So route table is your navigation for the packet. Your packet, when they need to go out, they would consult entries into the route table. If a entry is there for the destination they are going to, they would be able to take that path and then reach out to the destination network. That is the main idea of a route table. So this route table here is a navigation system, and as soon as you create a VPC, a main route table is automatically created for you. I'll show you that, and I'll show you what entries exist into that main route table. Right. So let's go to the console, and I would be showing you how that main route table looks like. So I am into VPC dashboard. I have route tables here. I have two route table. Now this can confuse you because there are no names. So what I'll do, I will find out which belongs to which VPC and I would name them so that we won't feel confused. So one belongs to default VPC, the bottom one, and this one belongs to the VPC which I am interested in. This is my Ireland route table. Let me put a name here so that it would be easy. So default route table, done. And now this one is my main route table, and I would say this is for Ireland VPC. That's what I have here. This is my main route table, as you could see, for that VPC. What is the meaning of a main route table? Main is like, let's say your laptop comes with Internet Explorer installed if it is a Windows machine. That is your main browser which has been given to you. But it doesn't mean that you cannot have another browser installed. You could install Chrome, Firefox, or any other browser of your choice. Similarly, if you do not make any changes, you would be using your main route table, right? Sorry for refresh here. But in case you want to change, you could go ahead and change it to any other route table. We will see that in a minute. I am interested right now to go to this route table and see what is inside this, what entry exists inside this route table. So I am into route table. See this thing here? Now, in this route table, I have option which says routes. So see this thing at the bottom. I'll go further down, make it a little bigger so you could see it. So this is my destination. I am into route section. There is a destination and which says 10.00/16 and which is called local. What is actually means? This actually means that, hey, if you remember, my VPC IP address is this one. So the VPC which I have created, that VPC has an IP address which is in range of 10.00/16. So it says, packet, if you have to go to this IP address range, anyone here, you do not need to go out. You are in good hand and you can locally talk to them. You do not have to exit the area within the VPC. So if you are a machine A who has an IP address of 10.0.0.0.15 and you want to talk to another machine which is 10.0.0, let's say 118, you do not have to go out because your first digits are matching the same, sorry, up to 16, so you do not have to go anywhere outside. So that is what we mean by an entry called local, and that entry always exists. This is status of active. If I go and try to edit it, I cannot modify this entry. I cannot delete the entry. If you see, there is no delete option available. I have to keep the entry, which will always be needed. Right, this entry cannot be removed, means it will by default allow you to go anywhere local, no issues at all on that. But that would mean that I can right now send packet only within my VPC but not outside. So that is the purpose of a main route table. And let me navigate to second tab here, which is called subnet association. So currently, which specific subnet are belonging to this route table, or which specific subnet will consult this route table to send traffic out? So see this information. This says explicit subnet association 0. I have not explicitly said someone, hey, use this route table, but as this is a main route table, see this? The following subnet have not been explicitly associated with any route table and therefore associated with the main route table. So if you do not have an association for the subnet, it would just associate itself with the main route table existing plus any future subnet you create. And if you do not specify a association with a route table, they would all belong to your main route table, which means all my subnet right now, AZB here, private, public, private AZA, public AZA, they are all referencing my main route table and through which they are able to communicate. So this is my main route table, which is an entry for 10.0.0.16 local, and all of my subnet are associated with it. So local communication, no problem. I do not have to define additional information. Everyone is able to talk to each of them, right? So can A talk to B? I'm considering I have not put any other restriction. Yes, A and B can talk. Can A talk to E or F? Yes, it can talk. Can C talk to G, H or EF? Yes, no problem, because the entry exists which says main route table entry is this. So the local communication is there and you do not need to make any extra attempt to make that local communication possible, right? But if you want to expand your network and you want to talk to external devices, let's say like internet. So internet exists, but we do not have right now a mechanism to talk to internet. How we establish a communication from VPC up to internet? So there are two-fold approach for that. First thing, we have to sort the physical connectivity, and second, we have to configure the software connectivity or logical connectivity there. So for that, we need to have a device which is called Internet Gateway. Internet Gateway is a software-hardware combination, a device or a resource provided by AWS which you can attach to a VPC. See this attachment happens to a VPC, and through which you are able to forward your traffic to internet. So let me go ahead and create a internet gateway, attach it to a VPC, and then we will see how the traffic goes outside. Right. So I am coming here to internet gateways. I have a default internet gateway. I am not interested in that. I would create my own internet gateway. So let me call it Ireland VPC IGW. Right. This is the name, and I have to just say create. Two-step process. I would create a internet gateway first. It would be created for me in a detached state. Once it is ready, the next thing would be I would attach it to a VPC, and I can only see one VPC here because the default VPC already has an internet gateway. It is a one-to-one relationship. You can't say, hey, I want better speed, let me add two internet gateway. No, it is a one-to-one mapping. One internet gateway will be associated with one VPC only. So this is what I have done, and I could say done. Let me attach my internet gateway. So what I did, I have made that connectivity up to my VPC level. But the challenge is, so physically that thing exists. Let's consider internet gateway is your airport. If you want to go outside of that location, you would go to airport, catch a flight and go outside. So airport is there, but your Google map is not aware about existence of airport as of now. Physically airport is there, but its entry doesn't exist in your navigation app, so you can't go to that airport because there is no navigation entry. So next thing would be we have to update our route table so that it can forward traffic to airport or to my internet gateway. How to do that? For that, we would add an entry into our route table, and that entry is called a quad 0 route, or it is referred as all 40 presented, or this is also referred as a default route. Give me a minute. Somehow my mouse was not working. Now it is working. So see this entry. This entry is representing 0. Let me write down 0.0.0.0/0. This is representing all IP addresses. Any IP address can be denoted in this format. So this is representing all available IP addresses. So let's read this. Now this route table says, hey, if you have a packet to send to 10.0.0.16, that will be considered as a local packet, and any other destination you want to talk to, go ahead to the airport internet gateway, and through which you should be able to move out. So if I add this entry into my main route table, everyone machine A, B, G, H, they would all be able to forward traffic to internet. So we could do that. Let me go ahead and add that entry, and then I'll explain why this may not be the best option. Let me first show the way of adding the entry, and then I'll say that you should avoid adding the entry in a minute. So I am into my main route table of Ireland VPC. I have routes here, and in that I would say I want to edit a route. This route already exists, and now I say I want to add a quad 0 route, 40 route, and that would be going where? See this? I could send the traffic to these destination. My requirement right now is to forward the traffic to internet gateway, and it will tell me which internet gateway. This is the one which is there, so I have associated it here, and then I can say save changes. So what happened now? All my subnet, current ones, and any future subnet I would create, they would all be able to access this route table, and through this route table they would be able to access IGW, and everyone would be able to communicate to internet. Now probably that may not be a very good design to allow every type of resource to communicate to internet. If you see this thing, I wanted to create some public subnet which will be communicating to internet and external world, and I would be creating some private subnet who should not be talking to internet directly. Now, when I create a subnet, I do not have option to say whether it is a public subnet or it is a private subnet. It is just a subnet. What makes a subnet public or private is the route table association. Currently, my route table has IGW entry, which means any subnet who is connected or associated with this route table, they would be public subnet. Whatever name you give doesn't matter. They would all have capability to send traffic out to the external world, and which may not be a good design for security. So what we should do probably, we should create another route table, which I would call now as my internet route table. Let me first create that and I'll then come back to the screen in a minute. So let me go to route tables here, and in the same VPC I would say I want to create a new route table. Let me call it my internet route table, and this would belong to my VPC, which is VPC01 Ireland. I would not give any other tags and say create a route table. So this route table exists. And what this route table can do, if somebody comes to it, it would be able to forward traffic to 10.0.0.0.16, and that's how it would be able to send traffic out. But currently, nobody is talking to this route table. Why? Because my subnet are by default associated to main route table, and main route table is having traffic entry for IGW, which is not a good thing. So what I should do, I should remove the entry of IGW from my main route table and transfer it to the internet route table, so that main route table won't have a way to talk to internet, and only internet route table would have a way to talk to internet. So let's go ahead and implement this into our AWS console. So I come here. You could add any time, like I could add an entry here first in the internet route table, and I would say, hey, you would be forwarding all the traffic which is not for 10.0.0.16 destination. Anyone should be forwarded to the internet gateway, and this is the internet gateway, and I can save the changes, right? I would go to my main route table and will remove the entry. So this is my main route table. I would go to routes here and I would say, let me edit the route, and I would remove this entry. So this is now not able to forward anyone to the outside world, which means what I have achieved this so far. But my public, private, all of them are referring to main. So probably you have guessed it. What we would do, we would now associate my public and public subnet in AZ1 and AZ2 to my internet route table, and then this architecture would be a better security approach for my application. So let me go ahead and do this thing here. I am into console and I am into my route table, which is my main. I won't do any changes there, but I would select my internet route table. I will check it's a subnet association, and if I see this thing here, it says it is not associated with anyone. Let me associate with, see this subnet are all associated with the main route table. I would say, hey, all my public subnet should be associated with internet based route table, right? One subnet can associate with only a route table, not multiple route tables. So it is a one-to-one mapping from subnet to route table, but one route table can be associated with multiple subnet. As you could see, current route table, main route table is currently associated with 4, and now I am changing. My internet route table will belong to AZB and AZA public subnet. These will be associated, and now I say save association. So now this internet route table is associated with my services here, as you see, and my main route table is associated with the remaining two subnet, which are my private, and this way we have created an architecture. Only public subnet can communicate to external world and private subnet won't allow to communicate. But still in this condition, D can talk to B, can talk to E, because it is still having an entry of local. So local communication is not blocked. It will still keep on functioning. Only the internet communication would be allowed from public subnet, and this is a better approach. What we host into public subnet, probably we would be hosting here services like my web server so that external people can access my web server. And maybe if I have database servers, I may not want it to be directly accessed, so I would host it into maybe private subnet and then let my web server communicate to my database server. Here shouldn't be a problem, but I don't want my database server to be accessed directly by external world. So that's how I would implement a solution in this manner. I hope you are clear here. Now let's keep on expanding this diagram. Now what if, let's say I have a database server here, and this database server has to download some patch from internet, right? Let's say a MySQL database is running here and we have a new patch coming from MySQL database and we want to download that patch from internet. But this machine D doesn't have a capability to go to outside world. Why? Because there is no route table entry. So what to do in these kind of cases? So what we are looking for here, we are looking for a private subnet machine to communicate to internet, and for that we would use a service or a component or a resource which is called a NAT gateway. NAT stands for Network Address Translation. What this is doing, this is basically translating your IP addresses from private to a public and then receive the response back and deliver it back to you. It is acting like a proxy server for you. I'll give you an example here, very basic example. So when COVID was there and lockdown was there, we had an elderly couple living in our apartment building. They were fearful of going out. Obviously they were at a very old age and then there were a lot of issues happening at that time. So what we did in apartment, then in the building, some of us volunteered to to go for them, get their groceries, medicine or any other thing they need. So they sent that detail to us and then we went on their behalf, got whatever they needed and then delivered it back to them. So person here would think, hey, this is Ashish getting the stuff, but probably I am getting that stuff for someone else. Right. I'm giving this example because I'm a vegetarian, and when I went to a grocery shop and I did some shopping for meat, that shopkeeper who was my friend was a little surprised at why I am buying this, because I was acting here as a proxy server for them. Similarly, what is going to happen here, that these machines can be configured to send their request to NAT. NAT would then forward it to internet gateway and get communication done. And when the response comes back, that response will follow the same path and then NAT will transfer that response back to machine D here. So that is what a NAT gateway is, which is a network translation. Now, a few things about NAT. NAT gateway is a managed service. So AWS will manage its availability for you within that availability zone. So if this NAT service crashes, AWS will recreate that, but within the purview or within the context of a availability zone, right? So be aware about that. If the whole, and what you could do, you could configure that all machines in private can send traffic to this NAT gateway for communication. It is not required that only the same availability zone machines can use it. It can be used by machines from other availability zones also. What I will do for that, two things. First thing, I have to create a NAT gateway, and once it is ready, I would add its entry into my main route table. So the benefit here is, as soon as DCGH have to send traffic out, they would refer a route table that will tell them, hey, forward your traffic to NAT, and then they would forward the traffic to NAT, and NAT already has access to internet gateway. Through this route table association, we would forward it here. So few things. First thing, NAT gateway are AZ specific. They are deployed into one availability zone. Second, they can access or they can be accessed by resources in other availability zone also. So this resource can also talk to them. So that is second thing, AZ specific but accessed across AZ. That is the second point. Third point, your NAT gateway would require to be hosted into a subnet which has IGW entry or which has a way to go outside. Then only it can carry traffic of someone else, otherwise it won't be able to carry traffic. So that is another thing which you have to be aware. Let me go ahead and implement this solution into console and we will see how easy it is to get started. So the next thing I am looking for here is to host something called a NAT gateway. So I'm on NAT gateway here. I do not have any NAT gateway. Now be aware there are charges associated with NAT gateway. So if you are doing this for practice in your personal account, even if it is company account, I would say do not just misuse any resource. So once your work is done, once you experimented, please delete that resource so you do not incur additional charges, but there is a charge on a NAT gateway. So I'll go ahead and say, hey, I want to create a NAT gateway. I would call it same name, my NAT. I'm not very creative with giving names, so let me call it my NAT gateway 01, right? Now, as I said, I have to host into a subnet which is public. I could host it into AZB public or AZA public, doesn't matter, but I would host it into AZA public and see this connectivity type public, that's fine. It requires something called an elastic IP address. I'll talk about elastic IP address into the next section, but let me right now just click this button which would give me a elastic IP address which has 5473 dot something entry, and once this is there I would say create a NAT gateway. NAT gateway may take little time to get ready. As you could see here, its state is pending, so it may take little time to get ready, right? Once your work is done, what you could do then, you could go ahead when this becomes ready, or even before that you can at least add an entry. I would now go to my private route table, or sorry, my main route table, and add a entry for NAT gateway. So this is my main route table which has only local communication as of now. Let me edit it. It can only talk locally, but I am now empowering it to talk to external world, but through whom? Through a NAT gateway, and this is the NAT gateway which we have just created. Once I have added this entry, I would save the changes, and what I have achieved so far, I have achieved a solution like this when my machines are able to communicate to external world without any issue. Now, if you want to make this NAT gateway highly available, you will probably look for having another NAT gateway deployed into another availability zone. Because what is happening right now, G and H are also using this NAT gateway. If this NAT gateway itself fails, AWS will auto create a NAT gateway for me, so it may have a disruption for a while, but it will again get started or again will be created for me, and that would keep me connected again. But what if the whole availability zone fails? So if the whole availability zone fails, these machines will keep on sending traffic to this NAT gateway which doesn't exist. So best practice, in case you want a highly available architecture to deploy a NAT gateway into another availability zone and use that to receive local traffic, what you would do in that case, probably you will create one more route table, associate only with this subnet here, remove it from here, and in that again entry of local will already exist, and you will add entry for NAT, but this time you will say you will be referencing NAT into AZ2. So that would be a better approach to apply connectivity to your services. I hope this thing is clear. Then saying it again, once your work is done, please remove your NAT gateway. Please remove the elastic IP address which was given to you. So this is my elastic IP. I should go ahead and first remove the NAT gateway and then release this elastic IP address so I do not get charged for it. Otherwise, there would be charges to pay. Okay, so we will expand this network architecture. We will add more component. Let's take a break and I'll talk to you into the next section. Thank you.